Welcome everyone. Today we're going to be trying to explain Django Rest Framework. So we're going to dive deep into the source code and how things are working internally so you can understand the framework you're working with. We're going to look at some pictures that I've drawn, some inheritance graphs, to really understand the fundamentals and where all the code is coming from. Again, more examples. We're going to look at the serializer class itself, learn about some Python fundamentals, like what is the init function on classes, the new function, what is this decorator method, stuff like that. We're also going to talk about when to use AI. So for example, when to use this cursor AI IDE that's quite new versus when to use Google. And a quick disclaimer is that this is going to be quite a fast-paced video. So if you don't have the fundamentals of Django Rest Framework, I would probably start by learning those. This video is structured by having different Git branches, where at each Git branch we're going to use more concepts from Django Rest Framework, check out quickly the pros and cons, and also highlight which parts are we taking for granted, so which parts are we relying on the framework to use. So in this first example, a couple of things we want to improve. We're using function-based views, so HTTP methods are separated by if and else statements, so we want to improve that. Status codes are not explicit, so it's just 201 and 400, which makes it easy to forget. And JSON response is not very flexible. We'd like to be able to return XML, HTTP, whatever you want really. And in this example, we are also using a Django Rest Framework concept, which is mainly the serializer. So here we inherit from model serializer. And so it's good to acknowledge here, at least if you're a beginner, that you are taking some code for granted. If you haven't looked into the source code on how this actually works, you're just assuming that this is capable of serializing JSON into Python objects or the other way around. Right, so let's just start improving what we just talked about. So we can check out the next branch, which is the request response branch. And now we're using Rest Framework's response object. So that's the main difference between the previous branch. So you can see now we have returning this response object, which is much more flexible since we can return XML, HTTP, and JSON among other response types. We've also added more explicit HTTP status codes. So now you can remember easier that this is created and this is a bad request, for example. Again, still using the serializer in the same way. So nothing much has changed, but we've already improved a little bit on what we talked about. Right, so moving on to the next branch, we're going to talk about class-based views. And here's where we're also going to begin to slow down and really dive into the source code and understand the framework. The reason being is because now we're using REST framework for almost every part of our API. So we're inheriting from APIView. So the first thing I want to dive in is because I learned a lot from looking at the source code of how serializers work, especially when you pass in the keyword many is equal to true. So if we go down this kind of chain, we have this custom user serializer, which I define, and the model serializer, which comes from REST framework. So model serializer, this inherits from serializer and so on until you get to base serializer. And here's kind of where that logic is handled. And this is also where I learned about, the init function, the new function, and what this decorator does, add class method, which are kind of fundamentals to Python and how objects are created from classes. So, for example, this new function, the new and init function are always called when an object of a class is being created. So you can override them like they did here, but if you don't override them, they're implicitly called. And the new function belongs to the class and not to the object, which means that you can call this method directly on classes, for example, here. So class is implicitly passed to this method, which comes from here. Through this whole chain again, where you go through serializer, base serializer, and then you're here. So finally, that class is passed into this parameter, which is the base serializer class, which we can then call the many init function on the class, because we're not working with an object of that class yet. So that's how the new function works. You can override it to change how you want objects of that class to be instantiated. And the class method decorator is very similar. It makes this many init function belong to the class and not to the object. And that's why you can call many init directly on the class. So that was kind of interesting. I learned, okay, we have this class method decorator and we have this new, and they're implicitly called every time you create objects. And then there's also this init function, which is called after new is called. And this works on an object of that class instead. And that's why you see the keyword self, because self refers to the object of that class. It's kind of like the this word in C++ and so on. So new is called, then init is called, and that's how instances and objects are handled in Python and in classes. And to actually look at the functionality of how this is working, it basically checks the keyword arguments and it pops many. If many isn't included in the keyword, it defaults to false, and basically the superclass is just called, the constructor that is. But if many is passed, like it's passed in here, many is equal to true, then we enter this kind of conditional statement where we call the many init function. Right, and then this is kind of a lot of code. So this is where I want to talk about also this cursor AI. It's an IDE that I've been using to kind of have an AI partner directly in my IDE. And I think this is a really good example of when AI is useful to use in comparison to Google. It would be very difficult to search up how this many init function works on Google. But here I can just ask the AI, like, can you break down the steps the many init function takes? And then it's going to give this like more human readable text, so you can just read through this, gather the context, and you don't have to fully understand the source code, just understand more or less the context of what's going on. So I don't understand exactly how it works, but I do understand that basically the main important thing is that you create a child serializer, which is this custom user serializer, and that's going to be used to handle serializing the objects based on the query set. So for every user, we're going to use the custom user serializer, and the parent serializer, which is the list serializer, is just going to loop through all of the objects in the query set. So list serializer takes the query set, uses the child serializer to serialize each unique object, and that's the basic idea. So again, you can dive in and really understand each line, or you can just get a general picture. All right, so hopefully now we've understood how the many keyword kind of influences object creations for this class, and we can move on to kind of our final branch, which is about using generic mixins. And so now we've gotten the code to be very concise. It's just 6 lines of code to do everything, the same functionality as where we started from, which was more like 20 or 30 lines of code. But here's where we have to really understand what is going on, because almost everything in the code here is dependent on a framework that we didn't write ourselves. So this is where I've been struggling for some time to understand what are the possibilities, what are the correct ways of doing things, because it all felt still a bit like magic because I never actually looked at the source code. So what I will try to do today is break down how REST framework kind of extends Django, and hopefully make it easier for you guys to understand this execution series. So what is called first? How do you create objects? How do you update objects? Where is all of this functionality coming from, really? So it all starts with the Django view. So this isn't Django Rest Framework. The Django view implements a HTTP request and a HTTP response. And Django Rest Framework defines an API view, which inherits from that Django view. And the main difference is they use their own request and response objects. And as we saw kind of in the first and second branch, the main benefits of those are that they're more flexible. They accept various data and they can also return various data. So not too much functionality added here. But then we get this generic API view, which again extends just the regular API view. And this is where kind of most of that logic that's provided for free, in a sense, is implemented. So the generic API view has fields like the query set, the serializer class, and the lookup field, and it also has methods. The query set defines what objects will be worked on. So for example, here you see that the query set is just all the users. So yeah, that defines what objects the serializer will be working on, and those things. The serializer class defines which serializer will be used to actually convert objects between JSON and Python native like data types and vice versa. And the lookup field is like the default way to look objects up. So if you don't set it, it's just the primary key. So for example, here I haven't set it, which means that users will be found in the database using the primary key. So those are the three most important ones there. Then you have methods like getObject. GetObject right here, it basically filters the query set of the view to find an instance. So that's what the getObject function does. The getSerializer class just returns the serializer class that you defined here. So it's just a getter and setter method. And the getSerializer method returns an actual object of that class. So here I kind of broke down what the getSerializer does. It calls getSerializer class to actually get the class. It sets the context, so any additional information you want to pass to that serializer, and then it returns an instance of the serializer class with that context. So that's why getSerializer will actually give you an object. So that's how generic APIView kind of works. It's the most important parts of it. And you can see again here, if I don't go too quick, I can kind of go through here to the list create APIView, and here to the generic APIView, and then you can see the things that I'm saying, right? It has a query set, it has a serializer class, it has lookup field, it has these methods that we talked about. So those are all implemented there. And now let's have a look at the create model mixin, or just mixins in general. So here I kind of have this box, which is just mixins which you can kind of compose with generic API views. So you can add different mixins to this generic API view to give it functionality to, for example, create objects or update objects or delete them. And you can choose what functionality you want. So let's have a look at the create mixin. Right, so the create mixin, if we actually look at the source code, we can see how that's working and understand the flow. So we have this function create that's called when we make a post request, for example, and we use the serializer, or we get the serializer from the getSerializer method. So again, I explained from this graph what the getSerializer method does. It basically returns an instance of the serializer with any context set. So now we have the serializer. We make sure to check that the data is valid. If it's not, we raise an exception because we don't want to be saving invalid objects to the database. So if there's no exception that's raised, we call perform create, which is again this function here, which basically just calls serializer.save. Again, you can look into how this functionality works by diving into the serializer and finding the function save. But basically, if it's a new object, it saves it to the database. If the object already exists, it just updates that entry. And then the headers is not so important. It just returns a response. That's whatever the data is with the correct HTTP status and some headers. So you can see that the generic API view uses the create function and kind of binds that to post request. And it does that, gets the serializer, calls as valid, and then performs a create, and then returns a response. And that's more or less the same with all of these mixins. It binds HTTP requests to methods, and the functionality is implemented there. So hopefully that kind of makes your mental model of Django Rest Framework a little bit stronger, and you don't take these things for granted as just like, okay, it works, and instead you take a different approach, which is really understanding how does it work, where is this functionality coming from, what is the sequence, so what is being called first, and you can just use all of this to make your code just much more concise. But it is important that you understand where the functionality is coming from. So I hope you guys enjoyed this one, a bit more technical backend using Django, and really looking at some professional software in that sense, because it's source code written by some just really good developers.